Okay, so you may be wondering what a one-way ANOVA is. And a one-way ANOVA is just used to compare the means of more than two independent groups. So in the last lesson, you've learned how to do means and proportions of two independent groups, or one sample proportion, one sample mean. And a one-way ANOVA is used when you're comparing more than two groups. So for one-way ANOVA, we use the F distribution. So you guys have already learned about the Z and the T distribution and how you compute test statistics and look up those test statistics to find p-values. So we do the same thing for one-way ANOVA using the F distribution. So we'll compute F test statistics and then determine a p-value for our one-way ANOVA. So like the T distribution, the F distribution has degrees of freedom as well, but the F distribution has 2 degrees of freedom instead of just 1. So the 2 degrees of freedom are known as between groups and within groups. So starting with the between groups, this may also be known as the numerator. That degrees of freedom you can calculate by taking the number of groups minus 1. And then the other degrees of freedom is known as within groups, also known as the denominator. You can calculate that by taking the total sample size with all the groups combined, and then subtract k, which is the number of groups again. So again, we're going to use the same 5-step hypothesis testing procedure for one-way ANOVA. So our first step is to check our assumptions and write our hypotheses. So there are 3 assumptions for a one-way ANOVA. So the first one is that your samples are independent of one another. The second is that the response variable is approximately normally distributed, or that all your sample sizes are at least 30. And then finally, it's that the population variances are equal across responses for the group levels. So really, that's just measuring the standard deviation across the groups. And then once you check your assumptions, you're going to write your hypotheses. Your null hypothesis is that all of the means are equal to each other. So it would be mu1 is equal to mu2, equal to mu3, and so on and so on. And then the alternative hypothesis is just that not all of your means are equal to one another. So our second step is, again, to calculate the test statistic. So when you're calculating the test statistic, you'll be using Minitab Express. This will provide your degrees of freedom. So it'll provide your between, within, and then the total of between the two. And then it will also give you an F test statistic. So once you have your test statistic, you can determine your p-value using your degrees of freedom, both the numerator and denominator. And then you'll make a decision whether to reject or fail to reject the null hypothesis, and then state a conclusion at the end. So we're going to our first review. So a Stat 200 instructor wants to know how traditional students and adult learners differ in terms of their final exam scores. She collected their mean scores from a sample of students. What kind of test would be used here? Okay, so we're going to go with the answer here. So the answer is B, independent means hypothesis test. So this is just really testing to see if you can identify the type of test you would use if you're given a situation. So we would be using independent means hypothesis test here because we were given 2 groups. We have traditional students and adult learners. So we wouldn't use one-way ANOVA because we only have 2. We don't have more than 2. We wouldn't use one sample mean because we have 2 different groups here. So, and then it's just down to A and B between proportions and means. So we would be using a means hypothesis test because she's collecting the mean scores from the sample of students. A one-way ANOVA is used instead of a multiple independent t-test in order to avoid increasing the likelihood of committing a type 1 error. True or false? Okay, so our answer here is true. Really, this is just showing you that in order to reduce the likelihood of committing a type 2 error, you would use a one-way ANOVA instead of multiple independent t-tests, because technically you could use several different t-tests in order to test different groups, but a one-way ANOVA is just a more efficient way of testing those groups against one another, and it also reduces the likelihood of committing a type 1 error or having a false positive. So find the numerator and denominator, respectively, for the degrees of freedom for the F distribution. Okay, so if you didn't get your answer, you can take a moment and pause it. I'm going to go over the answer now. The answer is C, 2 and 242. So the way I just wrote it was just to identify the 2 degrees of freedom, but 2, the first number is the between, and then the second number is within. So we have degrees of freedom for between is the number 2, and then the degrees of freedom for within is 242. So you see on the chart there, we have the degrees of freedom. There are 3 listed: between, within, and total. And total is just between and within added up. And then between is also known as the numerator, and within would also be known as the denominator sometimes.